Welcome to Exponential Functions, Unit 6, Lesson 4/5. We're going to do example 2 now. For example 2, we've got a different function here. Our base is now 1/3, so it's less than 1, which our first example, our base was 3. It's a little bit different here. Our a value is 2. Let's write this down. Our a value is 2. Our b value is 0.5. Oh no, our h value, we have to factor this out first. So here, before I do h, I'm going to factor it out. So I got to factor out my b out of here. So it's really going to be 0.5. And here I'm going to have x minus 1 divided by 0.5 is 2. So that means my h value is -2, and my k value is also -2. Oops. My k value is also -2. Sorry about that. All right. That is too messy for me. I'm going to fix that up. All right, let's do the k value one more time. K is -2. All right, so first thing, again, our asymptote is y equals -2. We won't do that until we decide our interval on y. And our n values. So now we're going to fill the table of values. We need our n value. Our n value here, 1/3. Again, why is that? Because that is what my exponent is to. So there's my n value. So when I do my base table of values, because my n value is less than 1, my x value is going to be -2, -1, and 0. Why is that? Because it's actually larger on the right side, or the left side of my x-axis, so it's larger on this side of my x-axis. Look at the graph right here, than on the right side of my x-axis. So I start with -2, -1, 0. So here my first one is going to be 1/3 to the exponent -2, and that, folks, is just 9. Then I have 1/3 to the exponent -1, and that is 3. And then I have 1/3 to the exponent of 0, and the exponent of 0 is 1. So there we go. So there's my base 2 values, -2, -1, and 0. And this is going to be 9, 3, and 1. Again, why is it these x values? Because my exponent is less than 1. My base of my exponent is less than 1. All right. So there we go. Let's transform it up. So here I'm going to have -2. My b value is 0.5, so I'm going to multiply by the reciprocal of that, which is 2. Because 0.5 is a fraction, is 1/2. The reciprocal of 1/2 is 2. So that, and then I'm going to add 2. A lot of 2's going on here. So -2 times 2, -4 plus 2 is -2. Next one is -1 times 2 plus 2. This is 0. And then finally 0 times 2 plus 2 is 2. So there we go. There are my x's. Let's go for y's. So my first one is 9 multiplied by a, so 9 times 2, then -2. So here I'm going to have 18 minus 2 is my favorite number, 16. Next one I'm going to have is 3 times 2 minus 2, so this is 4. The next one I'm going to have is 1 times 2 minus 2, and this is 0. So there we go. There are my y values. So it looks like 16. I'm not going to go by 1s. Let's go by 2s, just like my previous example. So 2, 4, 6, 8, 10, 12, 14, 16. Don't really have any negative values here, although I do have a asymptote at -2, so let's go like this. There is my y values, my intervals. So the first thing I'm going to do is I'm going to graph my asymptote. So let's do that. We'll do it a nice lime green color, just like before. So at -2, do a nice little line there, nice dotted line. There's my asymptote. Then I'm going to plot my points. So my points are -2 and 16. -2 and 16, so right about here. Next one is 0 and 4. Maybe I should use a different color so I can see it. Let's go with red. So there's my first one, 0 and 4, so my y-intercept is really nice, easy there. And my last one is 2, 0, so right there. And I'm going to just connect the dots So as I can see, as I go from left to right, it's getting closer to the asymptote. So I'm just going to connect them. There we go. Do. Not bad for writing on a computer screen. There's my function, my y-intercept. This one's easy to see because it's axiomatic value, 0, 4. My asymptote, y equals -2. My range, y is such that y is greater than -2. Greater than because my value is positive, and is also above the asymptote and YER. My domain, I butchered it last time, I'm going to butcher it again, it looks like, but it's always the same, x belongs to the reals. Increasing or decreasing function, because it's going from left to right, it's going down, the y value is getting smaller and smaller, this is also a decreasing function. There we go. For transformations, I'm going to say see Google Classroom, or I'm going to put them at the bottom of the video. See below. And there we go, transformations of the exponential function. All right, we'll finish this off by looking at some homework. So here's the homework. There are some graphs here. First one is very basic. There's only an h value for this one. The second one, a, h, and k. There's no b value because there's no coefficient of x. Same thing here, no coefficient of x and no b value, but there is an a, h, and k. This one here, there is no h value. Why is there no h value? Because there's nothing being added or subtracted to the x, but there is an a, b, and k. This one has everything. And again, before you graph it, make sure you factor out the 3. This one here has everything again except for k. There's no constant at the end, but make sure again you factor out the b value. Things to say, state these 5 things. The answers are actually in your workbook, so you can see the answers or use Desmos. Thank you for listening. Bye.